Imagine trying to lift a stone tower taller than a building, weighing hundreds of tons, with no cranes, no hydraulics, and no engines. Now imagine doing it not once, but again and again. The Romans moved Egyptian obelisks across deserts, across oceans, and then raised them in the heart of Rome. This is how they did it. First, what are we talking about? An obelisk is a single piece of carved stone, usually granite, cut from quarries in Egypt. Some Roman-era obelisks weighed over 300 tons. The largest moved to Rome may have weighed more than 500 tons. That is not a normal building project. That is a logistical war. Step 1 was quarrying. The Egyptians already had centuries of experience cutting granite obelisks at places like Aswan. Workers used stone hammers to pound channels into the bedrock. Wooden wedges were driven into cracks and soaked with water so they expanded. Slowly, the obelisk separated from the rock. Then it was shaped and polished, often with inscriptions carved after the main form was complete. Step 2 was moving it to the river. Granite does not roll easily, and you cannot simply drag it over sand without preparation. The solution was friction management. The obelisk was placed on a heavy wooden sled. The ground was flattened and packed. Workers likely laid timber rollers, planks, or a prepared trackway. Lubrication mattered. Water, oil, and wet sand reduce friction dramatically. A huge workforce, pulling with ropes, could move loads that look impossible today if the path is prepared and the pull is steady. Once near the Nile, the obelisk had to be loaded onto a transport barge. This was not a small boat. It was a purpose-built floating platform, wide enough to stabilize a long stone beam. The obelisk could be slid onto the barge using ramps and controlled lowering. The Nile did the rest. River transport is the ancient world's cheat code. Moving by water turns an impossible job into a manageable one. Step 3 was the sea journey. When Rome began taking Egyptian obelisks, it was not just stealing art. It was moving national trophies. But you cannot ship a 500-ton stone on a normal vessel. The Romans used special ships, including giant cargo ships designed for extreme weight. Some sources describe massive ships later repurposed as foundations in harbors because they were too big to use again. The ship would sail from Alexandria across the Mediterranean to Italy. The route was dangerous and timing mattered. You do not risk this cargo in winter seas. The entire operation required planning around weather, tides, and port access. Step 4 was landing the obelisk in Rome. This is where most people's mental picture fails. Rome did not simply unload it with a crane. They used harbor ramps, capstans, winches, and controlled pulling systems. Capstans are vertical drums that allow many men to pull rope with far more control than brute force alone. Multiply that across several capstans, and you can pull enormous weight slowly, safely, and in a straight line. From the port, the obelisk was moved inland on a reinforced sled, possibly supported by rollers and timber frames. Roads had to be prepared. Bridges had to be checked. The Romans were obsessive about engineering, and this is where their empire advantage shows. They had the infrastructure to move giant loads through a city. Now the most dramatic step, raising it upright. This is the part that seems like magic, but it is physics and patience. The Romans built a lifting frame, essentially a giant wooden tower with pulleys at the top. They ran thick ropes over the pulleys and attached them to the obelisk. Then they used multiple capstans and winches arranged around the site. Hundreds of men could turn these capstans together, winding ropes slowly and lifting the stone. But it was not a straight lift. They used controlled rotation. The base of the obelisk was anchored near its final socket. As the ropes tightened, the obelisk slowly pivoted upward like a lever. The key is that the weight shifts gradually. At each stage, the rope teams could pause, lock the capstans, and stabilize the load. If one rope failed, it could kill dozens. That is why redundancy mattered. Multiple ropes shared the load. The frame was overbuilt, the ground was reinforced, and the entire project depended on coordination. A few men giving signals could control hundreds of workers, turning at the same rhythm. When the obelisk finally reached vertical, the base was guided into a prepared stone socket. Then wedges and packing stones locked it in place. Only after it stood safely would the scaffolding be removed. So why could Rome do this? Because Rome was not one city. It was a machine. It had money, manpower, roads, ports, engineers, and a culture that treated logistics like a weapon. The empire could gather thousands of workers, ship timber for scaffolding, forge metal clamps, and build custom ships. This was not improvisation. It was organized power. And the point of it was political. An obelisk was a message. It told the population that Rome controlled Egypt, controlled the sea, and controlled the gods of the old world. It was propaganda carved in granite. Here's the part to remember: the Romans did not need hydraulics. They needed leverage, pulleys, rope, capstans, and an empire that could coordinate people like a single engine. When you combine simple machines with disciplined planning, you can move mountains. If you want more ancient engineering that should not have worked, tap the video on screen for the next breakdown.